Hare Krishna. Today we are going to learn about the elliptic or the Kal chakra and how its position or the angle of inclination, how it changes throughout the year. In the previous simulation we saw how the change in position and the angle of inclination happens within a span of 24 hours or during the day, but now we're going to look at how it changes throughout the season. So for the purpose of this simulation, the location is Pacific Northwest, and I've changed the date to summer solstice. So summer solstice, as we know, the sun is the farthest north. It could be about 23.5 degrees north of east, and we'll run the simulation at 100x. So right at sunrise, we will see that the sun actually, see, right around at sunrise, 5:28 a.m., the sun is about 23.5 degrees north, right? So it rises in the northeast direction. And if you look at the angle of inclination, right, of the elliptic, it is about, let's say, maybe 45 degrees, right? And this is summertime, right? So in the summer, the days are longer, especially in the northern hemisphere. So in this simulation, we'll learn why the days are longer. So we will see that the sun is rising, right, north of east. Now it's not rising in the east, it's rising north of the east. And the angle of inclination of the elliptic would be pretty steeped. You know, as the sun rises, it will go all the way up high in the sky. And then it will set north of west. So you see, it's actually covering more than 180 degrees. So 180 degrees would be from east to west. But if it's rising north of east, and it's also setting north of west, so it's covering more than half of the circle, right? So I think it will get obvious when we look at it. So through the day, like as the day is moving ahead, you see how the angle of inclination is pretty steep. So it's 45 degrees in the morning, but now it's approaching almost 85. It's just 9 a.m., but the sun is already way high up in the sky, right? It's just getting steeper and steeper. And now the elliptic is approaching east, right, by noon. In the morning it was northeast, now by noon it's in east. It's going past east. And look at the elliptic, it's way up high in the sky, right? The sun is way up high compared to the horizon, and as the evening is approaching, you see the sun is going to set not in the west, right? It's going to set north of west, right? So you see, that's the reason the daytime is so long during the summer. Now, if you look at the night time below the horizon, compared to the horizon, look at the inclination of the elliptic. It's not too inclined, right? The path is pretty, it's about 15 degrees compared to the horizon. Now it's almost flat. And then also another thing, if you noticed, if you go back a little bit, as you already know, that sun actually set at north of west, right? And so when it's going to rise, again in the morning, it's going to rise north of east. So if you look at the distance between northwest and northeast, is less than 180 degrees. The flip side, the remaining part of the circle, right? The first part of the circle was when sun was out, it was out for more than 180 degrees. If you compare the point where the horizon, northeast to northwest, right, that part is more than 180 degrees during the daytime, and the remaining part would be less than 180 degrees. So the nights are really, really short. So now, by the time the sun rises again in the morning, right, sun rises pretty early, 4 a.m., right, just before 5 it rose. And if we look at the sunset, right, the sunset was pretty late. Now increase the speed a little faster, 11 a.m., Let's see. See, again, it's going to rise, set north of west. So it's been out for a long time. It covers a longer duration, and the angle is pretty inclined. And see, it's almost 9 p.m. in the night it sets. So now we know why the daytimes are pretty long during the summer. Now let's change this to winter solstice, so about December 21st, right? And then let's change this to, if you want to change it, AM. So this is the shortest day and the longest night. Well, let's see how that happens. So the sunrise should be pretty late. So now we try to track the sun. Right, sun's just about to rise over here, right, if you see. And sun's going to rise where? Well, sun's rising right around southeast, right? And look at the angle of inclination. The angle of inclination, you will notice during winter, you see how does not go so high, right? It's pretty less inclined. And then the sun is rising south of east and it's going to set south of west. So distance between southeast, the angle between southeast and southwest would be less than 180 degrees, and so your daytime is very short. Now the day is approaching. You see the angle is just getting flatter and flatter, as opposed to in summer the angle was increasing. Now this is just barely above the horizon, right? It's almost past noon, afternoon, and see it's not here. It's going to set in southwest. Not even west, south of west. So very short duration, about 4 p.m. sun's already set. And so the days are pretty short. Now look at what's happening. Look at in the night time, the angle of inclination compared to the horizon is pretty steep. Nights are longer, right, from southwest. And you see as the night progresses, this is on the other side of the horizon, you cannot see the sun, but it just gives you an idea how inclined the path of the sun is on the other side during the night. So it's almost midnight, and you see the angle is pretty steep. The night's still not over, right? The sunset in southwest, and it's going to rise not in the east, right? It's going to rise south of east, and that makes the nights pretty long, right? It's more than 180 degrees that it traversed. So that's the end of the simulation, and in the simulation we learned about how the orbit of the elliptic, how inclined it is during summer versus winter, what makes the days longer in summer and very shorter during winter. Thank you very much. Hare Krishna.